Picture the solar system like a campfire. Planets sit near the flames while far out, old icy snowballs drift in the dark. Every so often, a few tumble inward, heat up, and grow bright tails, even though their cores are only city-sized. Right now, 7 comets are diving toward the sun. It isn't a threat, just a busy moment. A sky parade with big floats, small ones, familiar faces, and one surprise. That surprise is 3I Atlas. The 3I hints it could be our third interstellar visitor after Oumuamua and Borisov. If that holds, we're catching a traveler born around another star, carrying a different recipe of ices and dust, a message in a bottle from elsewhere. As sunlight cooks it, the gases it releases become clues, letting us compare its chemistry to ours and ask what's common across the galaxy and what's uniquely homegrown. If that interstellar twist has you excited, like this video to help other skywatchers find it. Now you might wonder, how do we know these comets are coming? The answer is careful watching and a lot of math. Surveys scan the sky night after night. When a faint dot shifts against the background stars, software flags it. Astronomers measure that motion over several nights and fit an orbit. If the path curves like it's bound to the sun, it's likely a normal comet. If the path is a wide, open curve, like a sling by with no return, it could be interstellar. As the days pass, the orbit solution sharpens, like turning a fuzzy photo into focus. NASA on alert doesn't mean panic. It means attention. Telescopes on the ground and in space line up to collect spectra, fingerprints of light that reveal what gases are boiling off, and to pin down brightness changes that hint at the comet's size and activity. If any orbit ever pointed even slightly close to Earth, automated systems would flag it, teams would run impact probabilities, and you'd hear clear updates. For these visitors, the story is science and spectacle, not fear. Following along and want the next update? Subscribe for our upcoming comet check-ins. So what will we see? That depends on 3 big things: how much ice the comet has, how fast it releases gas and dust as it warms, and how close it gets to the sun and to Earth. 2 comets can be the same size and behave very differently. One stays quiet and faint, another breaks apart and flares like a spark. Sometimes a breakup makes a comet brighter in the short term. Sometimes it just crumbles and fades. That unpredictability is part of the fun. It's like following a live sports match. Stars, literally, are the stadium lights. As these 7 get closer, some might stay telescopic targets. You'll need binoculars or a small telescope to spot them. Others might cross the magic line and become visible to the naked eye from dark places. If that happens, here's what you'll notice: a fuzzy coma, which is the gas cloud around the core, and 1 or 2 tails. One tail is dust, curved and yellowish white. The other is gas, straighter and often bluish. The gas tail always points away from the sun, like a windsock. The dust tail lingers along the path the comet took, like footprints glowing behind it. Got comet watching tips or a favorite stargazing spot? Comment below to help beginners get started. What about our interstellar guest? If 3I Atlas truly comes from beyond our sun's family, its path will be a one-time visit. It will charge in, swing around, and leave for good. That short window is why scientists are excited. The data we capture now won't come again from this same object. We'll be watching how fast it brightens. We'll check what molecules it releases. We'll compare it to Borisov and ask, do most star systems build comets with the same recipe? Or are we sampling a cosmic menu with surprising flavors? You might hear the phrase perihelion. That just means the closest point to the sun on a comet's path. Many comets brighten the most in the weeks around perihelion. If a comet's perihelion is very close to the sun, it can become spectacular, or it can fall apart under the heat and tides. That makes predictions risky. The best approach is to follow updates as the date approaches. The light curve, the record of brightness over time, will tell the truth in plain numbers. Let's clear up a few myths while we're here. First, comets are not poison in the sky. They don't release harmful rays. The night a comet appears is safe to enjoy. Second, a bright tail does not mean the comet is giant. The tail is thin, so thin you could wave your hand through it like fog if you could stand there, which you can't. Third, a comet near the sun in the sky won't cook Earth. We get the same sunlight we always do. The show is a reflection and a glow, not a heat lamp pointed at us. So how can you watch? Start with a simple rule. Get away from city lights if you can. Even a short drive makes a big difference. Let your eyes adjust for 20 minutes. Use a star app to find the constellation the comet is passing through. Binoculars are perfect for beginners. Sweep slowly. Once you find the fuzzy glow, pause. You may notice the tail with averted vision. Looking slightly to the side of it helps your eyes catch faint light. If you own a DSLR or mirrorless camera, set it on a tripod, try a wide lens, and take a few 10 to 15-second exposures at high ISO. You may pull out detail your eyes can't see. If you want to help science, look into citizen science projects that collect comet observations. Even simple brightness estimates reported by many people help build a better light curve. If you're into coding or data, public survey images sometimes ask volunteers to tag moving objects. That work can flag new comets faster. Now back to our 7 travelers. Expect variety. One may remain a quiet smudge. Another could flare after a small outburst. A third might grow a long, elegant tail that stretches across a wide chunk of sky in dark places. And if our interstellar visitor behaves, we could get a rare glimpse of material that formed under another star's light. Whatever happens, each comet is a time capsule from the birth of planets. Studying them is like reading the first chapter of our story. There's also a practical side. Comets deliver clues about water and organic molecules, the stuff life likes. When we measure their chemistry, we test ideas about how Earth got its oceans and how often life's ingredients appear around the galaxy. Even small findings build a bigger picture. Are watery worlds common? Could life's building blocks travel far and wide? Comets help us answer those questions without leaving home. If you're thinking, this all sounds great, but I don't have a telescope, don't worry. Most of the learning and the joy come from simply showing up under the night sky. Grab a friend, bring a warm drink, look up. If one of these visitors does break into naked eye territory, you'll be ready. If they stay faint, you'll still meet new constellations and see planets, star clusters, and maybe the Milky Way if your sky is dark enough. Before we wrap up, a quick safety note. Never point binoculars or a telescope near the sun during the day. If a comet is close to the sun in the sky, wait for twilight or full night and use guides that show safe viewing times. Your eyes are priceless. Treat them like it. All right, space fans, here's your mission. Check the sky forecast for your area. Mark upcoming evenings when the moon is slim or below the horizon. Set a reminder for the perihelion dates the astronomy community highlights. And if you catch anything, even a faint smudge, snap a photo and share it with your local astronomy club or online community. Your shot might be the one that shows a new jet or a sudden change. If you enjoyed this tour or learned something new, like the video and subscribe so you don't miss our next sky guide. Tell us in the comments where you're watching from and what gear you're using. Binoculars, camera, or just your eyes. The sky is busy, the solar system is alive, and right now 7 wandering messengers are writing bright lines across the dark. Let's go read them together.